Question 19, provide the starting material for the following reaction. So we start off with this, we end up with this. We gotta kind of work backwards to figure out what this looked like before we did those 4 steps to it. So we're gonna actually start from the very last reaction that happened to it, KO-T-butyl. That's our big bulky base, the bulkalicious base, right? Bulkalicious bases do elimination. What's elimination form? Double bonds. This is our double bond that was formed by our bulkalicious base. So I'm going to redraw our finishing material right here. This is what we finish with. We know that when we do elimination with one of these big bulky bases, we need to eliminate something, right? And we could probably guess that we're eliminating a bromine. So let's start working backwards. Before we did the elimination, there was no double bond, and we could deduct that it was probably a bromine right here, because if we added a bromine using UV light, we would want to put it in the most stable position, and this position is actually the benzylic position, which is very stable, the most stable position found on this molecule, so that's where we would probably have our bromine. Okay, we've worked backwards a little bit, but we know that we added this bromine, so it didn't originally have it. So let's get rid of it and think that this right here is how the molecule looked before. Next, we see that the CH3I was added. And the I is a good leaving group on the methyl. So what happened? We had this bonded to the iodine. And we know that I is a really good leaving group. This methyl is great for SN2 substitution. And if we did our carbon counting, we would see 1, 2, 3, 4, 5, 6, 7, 8 carbons to start with. While in the final molecule, it does have this 9th carbon. So we could probably deduct that this is the 9th carbon that came in. So how did it get added in? Well, we see sodium hydroxide right at the beginning. Sodium hydroxide, that's a good base, right? A very strong base. So how did we get to do substitution on this? Well, we could think, what if this right here was an H, right? I'm gonna erase that for you real quick. What if we started with this? This is a phenol, right? If we started with phenol and then added the sodium hydroxide, the sodium hydroxide deprotonates acids. This is an acid right here, a pretty strong one too. It would come over, take the H, leaving us with O minus with all of our electrons, bonded to our benzene ring. This right here would act as our nucleophile. So we would come over, do SN2 on this carbon, kicking off that I, adding on the CH3. Okay, that all seems to make sense, right? So let's write out our final answer, what the starting material was. The starting material was this phenol, which is the name for an alcohol on a phenyl ring, makes sense, with the ethyl. We deprotonated it, we added on this carbon right here, we added on bromine, and then we got rid of the bromine to make the double bond. That's our answer.